Hello, I'm Lee. In this video, we are going to look at the linked list implementation of a sorted list. So let's take a look at this list class. I'm trying to model a sorted list here. So let's see, it has three constructors. One constructor is a default constructor with no parameter, and the one with the input file name. So for the second constructor, it will load data from this file and populate the list. And the third constructor is called copy constructor. So just in case the client needs to make a copy of a list. And we have a destructor, which is necessary because this is a linked list. So every node is allocated dynamically. So it's our responsibility to deallocate the nodes and the data associated with it when the list is dying. And also I overload the assignment operator to make a deep copy of the list. Now let's take a look at the public interface here. The first one is called insert. Insert will take a data and add this piece of data to the list. Because it's a sorted list, so this insert doesn't have an index with it. It's just based on the value, the key value in this data. I'm going to insert you at the correct position to make sure this is a sorted list. So the client doesn't have a right to specify exactly where to sort it. So there's no such parameter called index. Just give me the data. I'm going to insert it according to the key value. And now let's take a look at the remove. Remove is a pass me a key. I'm going to remove the object with this key, and both of them return boolean. So for insert could fail if you specify the list shouldn't contain duplicates. So if you already have that data there, it should return false. And remove, if you don't have that key, the object with that key, it's going to fail, give you back a false value. And retrieve work very similarly. Give me the key, I'll give you back the data with that key, but it won't remove it. It's just a retrieve. And display is just for debugging reason, and the get size to tell how many elements are there in the list. And write out will save whatever you have in the list to this external file. So when we exit the program, we will invoke write out to save the data to the external file. Alright, so that's a sorted list. This is a sorted list. And the data structure we're using is a linear linked list. And next week we're going to use an array to implement exactly the same behavior here. But for this week, that will be linear linked list. So for linear linked list, we know we have to define the node first. The node is very simple. It contains the data and a pointer to the next node. So this isn't a doubly linked list, because for a doubly linked list you need to keep track of the previous node as well, and it's not a doubly threaded linked list either, because for doubly threaded linked list you need two next pointer there. Alright, so this is to define the node. And for linear linked list, here we only keep track of the head pointer. So head pointer is a pointer that points to the first node of the linked list. So head isn't a node, it's just a pointer to the first node. It's kind of like this next pointer, it's just a pointer to the first node. So head really isn't a node. And also we want to keep track of the logical size of this list, and there's no physical size of this list because there's no capacity constraint for a linear linked list. Alright, now let's take a look at the implementation file. I'm going to pick on two operations to talk about. The first one I want to talk about is how to build a linear linked list. So this insert function. So for this insert function, take a look. I have two temporary pointer to help me traverse. So usually when you try to modify a linked list, it will be more convenient if you have two traverse pointer. You will see why. How about let me try to draw a linear linked list here. So this is a head, and this is the first node, the second node, and you see every node got two compartments. The first is to hold the data. So assume this one got 3, let's say. This one got 6. And it has the next pointer to point to the next node. So assuming we have 10 here, and that's the end of the linked list, so I'm going to give it a no pointer. And for this insert function, let's take a look. So if I'm trying to insert something, let's say 7. So trying to insert 7, the first thing I need to do is to create a node and put 7 there. Alright, let's take a look at the code here. First we traverse. So previous start with no. So previous, we have a previous pointer, and we have a current pointer. So this is previous, this is current, and we start previous with no and start current with head. So head is going to point to here now, point to this one, and previous start with no. And now we are traversing to find the correct position to insert. So let's see, while you're traversing previous, you assign current to previous. That means now previous point to this node, and the current update. So that's how it traverses. So it will be broken. That's how you do the traversing. And now let's take a look at the ending condition. While current not equal to no, that means well, I haven't hit the end of the list yet, and the current item is less than a data, so you haven't found the correct position to insert. You see those two conditions, this one comes first, that's essential. If you switch the order, so try to imagine what's going to happen there. If I put this second condition as the first one, so what if current contain no? So that means if it's an empty list, your code will crash right away. So current contain no, and you're trying to access a memory that pointed to by no, that's not there yet. So your code will crash. So I suggest every time when you do something, like when you type a pointer like this, or any pointer, anytime when you type this, you need to ask yourself, what if pointer is no? Then you need to know if pointer can ever be no, then this code will crash your program. So be careful here, don't switch the order. So we first test if current is no. If current is no, you never test this one because a short circuit evaluation of this AND operator. If current is no, you never get to this part. So this traversing part is say, okay, well, I'm not hitting the end of the list, and I'm not at the correct position yet. I'm going to keep on traversing. So in this case, our traverse will come to all the way here. Current will point to this one, and previous, it's getting messy, will point to this one. Alright, so at this point, current pointing to this number 10 node and previous point to 6. We stop traversing, so take a look. If current and the current item, again we do current testing first, equal to data. So 10 isn't equal to 7. So this is we're trying to test if the data already exists. So 7, it doesn't exist, we come to the else case. In the else case, let's see, we create a new node and set up the new node. You see, the reason we can use this assignment operator is we already overload this assignment operator in the data class, so that we don't have to worry about which field are there in the data. So will we get a shallow copy or deep copy? We will simply trust this assignment operator do the right thing. And now let's try to take a look at, oh sorry, we keep on moving on, and to this part of the code we are trying to link it together. So trying to link it together, I need to draw this one so that you can see what's going on there. So from the previous traverse, our previous pointer is pointing to this node, and our current pointer is pointing to this node. So, and this is our new node. This is our new node here. So we are trying to make the connection here. New node item equal to data. So remember this one, if I give it 3, this one if I give it 10, this one is 7. So I need to make the connection like this first. So okay, this is new node. This is a new node, so that will be new node next equal to current. So first make this connection, then we need to make this connection, and this pointer is previous next equal to this one. So you see, we first link the new node next equal to current, then we are trying to do previous next equal to new node. Remember, every time when you do this, you need to ask yourself, could previous be no? Every time when you do this, you need to ask yourself. So new node isn't no because we just allocated, so there's no trouble. So this connection is fine. New node next equal to current. But previous next, what if previous is no? And it could be no. Remember, you initialize previous with no. So what if you're trying to insert at the beginning of the linked list? If I'm trying to insert it here at the beginning of the linked list, then my previous pointer is no. You never enter that loop, so it is no. If it's no, then this one will crash your code. So we first test if previous is no, that means we want to make this connection. So we want to make this connection just head equal to new node. Alright, so that's about this insert function. And this is pretty much the algorithm is to traverse to the correct position, then link the new node into the list. Now let's take a look at another operation here. Another operation I want to show you is this one, how to copy a linked list. How to copy a linked list. So this is a passed in linked list, and we're trying to make a copy of this list. So let's take a look at the algorithm. We first copy the first node. So head equal to new node, head item equal to this passed in head item. So we first copy the node here. And then we say destination node and the source node. The destination node, we give it a head. So how about So we're trying to copy this list. This is passing in a list dot head. So this is a list dot head. List dot head. We're trying to copy this list. So first we copy the head node. So we copy the head node. And then we are trying to copy the rest of the node. We need two temporary pointers. One is called the source node. So source node, we initialize it with a list.head next. So this is our source node. I'll just use S. This is our source node. And also we need another one called the destination node. Destination node, you see this is destination node. We initialize it with head. This is head. So this is destination node. Okay, this is head. And then we test, is source node equal to no? If it's not equal to no, that means we need to copy something here. So how to make a copy? That means, oh, you have a next node to copy. So let's take a look. So destination node next, which is this pointer. You allocate a new node. Allocate a new node. And update your destination node. So update this one. Now my destination node move on to this one and copy the element. So here you copy the element and update your source node. Your source node will move on to this one. So you first test the source node. Is that no? If it's not no, I'm going to say destination node next. Okay, you see that's how it goes, how to copy a linked list. Thank you.